Hello, my name is Josh Obert, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the WASCOB tool. This is the third tool in the impoundment siting section of the ACPF Toolbox. This tool will be siting water and sediment control basins. WASCOBs are more than just a funny word. They're small embankments built across small drainage ways in agricultural fields, and they have a lot of potential. They can reduce sediment and total phosphorus loads. They have decreased peak runoff discharge and can lessen gully formation. The NRCS recommends installing them on watersheds from 2 to 50 acres in size. Let's get the tool started before going over some more details. In ArcGIS Pro, we will open the catalog window in the right side of the screen if it isn't already open by clicking the catalog tab. Expand our ACPF toolbox and expand impoundment siting. Double-click the WASCOB tool to open. This tool has 8 inputs that it's asking for. The first is our field boundary feature class, and we can add that in the first dropdown as it is currently in our map. When choosing the field boundary feature class, 4 of our other inputs auto-populate. These are our flow accumulation raster, our flow direction raster, our stream reach feature class without water bodies, and then our watershed boundary. The next required input is our unfilled DEM. That's our new DEM, which is also in our map, so we can choose it from the second dropdown. A default of 1.5 meters has been provided for the embankment height, which we will keep, but feel free to change this. It just must be within the range of 1 and 4.5 meters. The tool also asks for a z-factor, once again 0.01, and the output we're going to get is our WASCOB's feature class in line format. Click Run to run the tool. Here's a brief explanation of how the tool works. Flow paths that drain at least 2 to 50 acres are found, and then points are created every 200 feet along those flow paths. These points must be within agricultural fields. Pasture is included in this case, so the ISAG value can be equal to 1 or 2. We then test to make sure that there won't be flooding happening. So if the elevation change between one point and the next upstream point is not enough, and that upstream point would be flooded out, the point is removed. With the points that are still remaining, a 100-meter wide transect line is drawn perpendicular to the mean direction of the flow of that particular drainage way. In the next step, the elevation profile of each transit line is taken and analyzed to make sure that both of the following criteria are met. First, each side of the drainage way must exceed the elevation of the embankment. In our case, we chose the default of 1.5 meters, so it must be higher than that. And this is to ensure the curvature to necessitate a WASCOB. Secondly, each side of the drainage way must not exceed twice the elevation of the embankment height. This is to make sure that the WASCOB is not too incised. In our example here, the first one is a success. Both sides are greater than the 1.5 meter embankment height, and both are also below twice the embankment height. The second one fails as the one bank is less than our 1.5 meter embankment height. In the last couple steps, any WASCOBs that touch each other are within 25 meters of the stream reach or intersect the field boundary are removed. Finally, information on upstream drainage area to each WASCOB is calculated. The WASCOB tool has finished running, and we can see that the results, a WASCOB's feature class, has been added to our map, and there are quite a few results. Let's zoom in and take a closer look. In our hillshade, flow would accumulate in these areas at the bottom of the slopes. And it makes sense that the WASCOBs are placed there. And in general, they're all perpendicular to that downstream direction. Right-click on the WASCOBs in the table of contents and click Attribute Table. For each result, we have a WASCOB ID, the contributing area in acres, an elevation, the embankment height in centimeters, and both bank heights, also in centimeters. We also have the length of each WASCOB. We sort by the contributing area field by right-clicking on its header and sort ascending. We have quite a number of WASCOBs that have a contributing area just over 2. As we scroll down through the table, we get to the higher values of contributing area. This could be a way to prioritize your selection. You may want to build ones that treat more area compared to smaller areas. To recap, we ran the WASCOB tool and discussed how it was determined where they would be placed. In the next video, we will run the final impoundment siting tool, WASCOB basins.